In the second half of Unit C of Algebra 1, students spend time describing reasonable domains and ranges for real-world scenarios. The domain is the set of x values, or inputs, that are possible for the scenario. The range is the set of y values, or outputs, that are possible for the scenario. Students also use function notation to find properties of graphs in relation to the real-world scenario. In this video, we will be taking a look at Lesson 11, Task 11.3. Take a moment to read the task and also the problems that students are asked to solve. In this task, questions 1 and 2 are in function notation, which follows from the first video in this unit. So again, function notation is just a quick way for us to see the name of the function, the input of the function, and the output of the function. So here for number 1, it says we want to find h of 0. So h is the name of the function, and inside the parentheses is the input of the function. Now, the input of a function is also known as the x values of a function, or the independent variable. And this is the x-axis. This is asking what happens at function h when my input is 0. So this is asking when the x value is 0. So when I have 0 time or 0 seconds, it's asking what's happening with this function, or what is the height when we have 0 seconds. And at 0 seconds, if we're talking about a tennis ball that's being dropped from a certain height, this is just the starting value. So my tennis ball starts at 6 feet above the ground. So the height is going to be 6 feet at 0 seconds. Number 2 says when a solve h of x equals 0. And again, h is just the function name that's just telling us that we are looking at this graph right here. If we had a second graph and we had a different function name, we would have to pay attention to see which graph we will be looking at. So it's asking us, when does function h have an input of x at 0? So this 0 here isn't asking us about the seconds, because the seconds lives inside the parentheses here for the input. It's actually asking us, when is the height, or the output, 0? So height is 0 means that when does this tennis ball hit the ground, when it bounces off the ground. And there are numerous times when this tennis ball hits the ground. If we follow the path of this tennis ball, it starts at 6 feet, it goes down, it bounces right here, goes back up, goes down, bounces again, a third time, a fourth time, and it hits the ground a fifth time. So number 2 actually has 5 answers because it's asking what times or when does this tennis ball hit the ground. And this tennis ball hits the ground at 0.54 seconds, 1.48 seconds, 2.25 seconds. And these last 2 times when it hits the ground, we don't have a number given to us. So we're going to have to estimate it a little bit. So this is a little bit after 3, but before 3.5. So I will say maybe 3.02 seconds. And again, this last one here is between 3.5 and 4, but a little bit past the halfway point. The halfway point between 3.5 and 4 is 3.75. So we would say this is maybe 3.76 seconds. As long as the estimate for this is relatively close to what numbers we are given, it is perfectly fine as an answer. Now, number 3 and 4 are talking about the domain and the range of the function. So when it's asking about the domain and the range, it's asking about a reasonable time for the domain, because domain is the x values or the inputs of the function that can happen. So we have to ask ourselves what times are possible for this tennis ball. Even though the graph starts at 0, we kind of have to think about, can time happen before 0 or the negative numbers? And no, we don't really have a time machine yet, so we can't go back in time. So the domain of this function, where possible times for this tennis ball to drop and keep bouncing, has to start at 0 seconds. So I'm going to write this down here. So the domain will start at 0 seconds. And the next thing for this graph, for this function, I notice is right here that it says that this is a partial graph of h. So we know when we have a tennis ball and we drop it and it's going to bounce a bunch of times, it's usually not just going to bounce 5 times. It's usually going to continue until it gets stopped by something or runs out of momentum. So we're going to say that it'll continue, being that this is a partial graph. We don't know when it actually stops. So it's going to start at 0 seconds, and it'll keep going until it stops. Another way of writing this domain would be between 0 seconds and when it stops. Number 4 is asking us to describe the range of the function. Now this is very similar to the domain, where the domain was the set of all x values or all inputs, or the time it took for this ball to start and stop. Likewise, the range is the set of all y values or inputs or all of the heights that this tennis ball could possibly reach. So we can see here that the tennis ball starts at 6 feet above the ground. It falls until it hits the ground at 0 feet above the ground, and then it bounces up, bounces down, and keeps going. Now this tennis ball never goes above 6 feet above the ground. We can see that in the graph here. And we also can see in the graph that this tennis ball never goes underground or go into the negative numbers. So the range for this tennis ball is going to be between 0 feet, because that's when it hits the ground, it doesn't go underground, and 6 feet, because it never goes higher than when it initially started at 6 feet.